Here is a problem about glasses. An older man finally breaks down and gets a pair of bifocals. His near point without the glasses is 25 centimeters from his eye. His doctor prescribes him glasses where the distance lenses have a power of negative 1.5 diopters and the reading part has a power of plus 1.25 diopters. His glasses sit 3 centimeters from his eye. In part A, we want to know how far is his near point if he looks through the distance lenses, that is, if he didn't have bifocals. So let's draw the picture. Here is the eye, and this person has a near point and a far point. So that means that the person can see clearly anywhere from this point on to this point, and anything beyond or too close to the eye is going to be fuzzy. So if the person wears just the glasses for distance, the distance lenses are diverging lenses. Another reason that we know that is because we have the focal length as 1 over the diopters, so it's 1 over the negative 1.5. A negative focal length goes with diverging lenses. So the point of diverging lenses is to bring an object closer to the eye. So in this case, it will bring anything that's over here closer to the eye. Now, that means that the former near point is going to be brought closer so the eye can't actually see it. So that means that we have to put an object farther away so that the image in these lenses will be formed where the naked eye can see it. So let me draw some pictures here. So if we place the object at this location now, the diverging lenses will bring the picture will form an image where the naked eye can see it at that 25 centimeter distance from the eye. So then this will be the object, and the object distance is going to be farther away than the image distance. The other thing that we have to pay attention to is that the image formed in glasses is always going to be in front of the glasses. So it's going to be a virtual image and the image distance will be negative. So let's write down the object distance and the image distance. And remember that we have to do that in terms of the glasses. We know that the distance from the near point of the person to the eye is 25 centimeters, but we also know that the distance from the glasses to the eye is 3 centimeters. So then the image distance will be negative 25 minus 3, or negative 22 centimeters. The object distance is the thing that we're looking for. And what we know is the power, the refractive power, which is 1 over the focal length in meters. And that was given to us as negative 1.5 diopters. So then when we write 1 over F is 1 over DO plus 1 over DI, this 1 over F is actually the diffractive power. So we have to convert DO and DI into into meters from centimeters, because we know that F has to be in meters for the diopters to be negative 1.5. So then the centimeters here I'm going to have to convert into meters. So I solve for 1 over DO, and that's going to be 1 over F minus 1 over DI. But really what I'm interested in is DO, so that is 1 over F minus 1 over DI to the negative 1. 1 over F is negative 1.5, and 1 over DI is 1 over negative 0.22 meters, right, to keep the unit straight. And this is all to the negative 1. So when we solve for this, we get DO to be 32.8 centimeters, and this distance is from the glasses. So that means that DO from the eye is going to be the 32.8 centimeters plus the 3 centimeters, so it's 35.8 centimeters away. So what this says is that if you're putting glasses on to see far away, you actually have to move a book that you're trying to read farther away from your eyes to still see it clearly. If you take those glasses off, you can bring the book close to your face again because you can see closer up without those glasses. Now in the second part, how far is his near point if he looks through the reading lenses of his new bifocals? So for the reading lenses, this is the eye, and again the person has a near point and a far point. The types of lenses for seeing close up is this. So they are converging lenses. And in the case of a converging lens, what happens is that it takes an object that is too close, so this would be the object, and it moves it back to where the naked eye can see it. So this is the image. So let's look back at the previous question. We had diverging lenses, and the way they worked was that they take an object that's farther away and bring the image closer to the eye. With converging lenses for reading glasses, the lenses will take an object that is too close and move it farther back. So the naked eye would have to look at the image, which is at the near point of the eye. So now the image distance is actually the same as it was in the previous problem. It's still a negative number because it's a virtual image, so it's negative 25 minus 3 because the glasses are 3 centimeters in front of the eye, so that is negative 22 centimeters, and I'm going to convert it right away in meters because I know I'll have to, so it's negative 0.22 meters. The power, the refractive power this time is plus 1.25 diopters, plus because they're converging lenses. And now I'm going to use 1 over F is 1 over DO plus 1 over DI. So DO will be just like in the previous part, 1 over F minus 1 over DI to the negative 1, but the signs are different now. So we have 1 over F is positive 1.25, and then from that we subtract 1 over 0.22 meters. So this one is positive. Am I right? No, it's also negative, sorry. Negative. And then if you plug in the numbers, you get 17.3 centimeters. So again, this distance is from the glasses, but we are interested in the distance from the eyes, so we have to add the 3 centimeters and get 20.3 centimeters from the eyes. So that means that the person would have to hold the book at 20.3 centimeters and look through the glasses to see the image formed at 25 centimeters.